of 14.5 is writing out the equation if I'm just giving you a maximum and a minimum. Third hour realized that this was even easier than using a graph because there's not a lot there to mess you up.
Yeah.
So what we're going to do here is read it and say that, all right, your maximum's at A, your minimum's at B for all of these problems. So this being a max, this being the min, what I'm going to do is just kind of do a rough sketch of the points themselves, because then it's very easy to identify sine versus cosine and everything else. First ordered pair is at 0 and 3. That's my maximum. Right away, notice I'm starting my graph at a maximum. What does it have to be? Cosine. This has to be a cosine curve. The next one is at 2 pi and negative 3. Does it matter where I put 2 pi? No. And here's negative 3. So if there's a maximum and a minimum, if it starts at maximum, goes to minimum, we know it's got to be a cosine. Are the distances between the line y equals 0? Correct. There's no shift because the absolute values of the y coordinates are the same. So there's no k. We also can tell them what your a value is. If it starts at a maximum, will a be positive or negative? It's going to be positive, so a is going to be a positive what? 3. Lastly, how far apart is it from 0 to 2 pi? 2 pi. So our period is 2 pi, and I set that equal to 2 pi over. Oh, I forgot. Sorry, I forgot to double it. And I set that equal to 2 pi over b. What's b? 1/2. Very good. So b equals 1/2, and you're done. 3 cosine, 1/2 x. Yep. Pretty easy, isn't it?
Yeah.
Do the next two.
If you insist. So A is always going to be max, B always.
So, is there a vertical shift in the first one?
No.
Why not?
Because it's the same absolute value.
Okay.
In your y value.
This problem did not start at a maximum, therefore it had to start where?
At the origin.
In this case, it started at the origin because there's no vertical shift. So that tells you it's what kind of a graph?
Sine.
We know it's a sine graph with an a value of 8, very good. And it's positive because it's maximum. How far apart is pi and 2 pi? Or,
2 pi.
yes, so there are 2 pi. Double it. So b is
So your equation is like 8 sine 1/2 x.
perfect.
Wow.
I always forget to double it.
I like that.
And then the last one, this one, they don't have the same y value, which means there's a vertical shift. You agree? So we start. Our maximum is at 9 pi.
So just plot it out somehow nicely.
Sure. Maximum's at 9 pi. Your minimum's at 3 pi and 5. So it hit the minimum first, then the maximum. So is your a value positive or negative?
Negative.
A value has to be negative. Is this sine or cosine?
Sine.
Again, why?
Because it does not start
Good.
at.
And our a is going to be negative. How far apart is 1, or what's the midpoint of 1 and negative 5?
6. You get negative 4 and then you divide by negative.
Right. I was saying the midpoint, we're finding the midpoint of those two.
So it's like
Your k value is negative 2 then.
you can just play like the game, you know, where you like in the median.
Yeah. So now your a value is 1 little, 2 little, 3 little spots. It can go either way. A is positive. I just went that way. That's all. Okay. A is that. Now, how far apart is 3 pi and 9 pi?
6 pi.
Double it, you get?
12 pi.
All right, so 12 pi is your period, has to equal 2 pi over b. What's b?
1/6.
Good.
For 1/2 inch.
Yeah. So now you have -2 minus 3 sine pi over 6 x.
Wait, it's just
1/6 or, oh, did I write pi over 6? I'm sorry. I was in the habit of writing pi. I've been writing pi's all day, so I'll just say,
it's okay.
1/6.
I understand.
Okay, so 1A, basically what you do is you take the difference between the two and then divide by 2.
Yep.
That's exactly what you do. Oh my god. I'm gonna put where.
-1 minus, or -1 minus -5 is 6 and half
I
is
actually
3.
did that right.
Yeah, so you probably just
Negative
-5.
Okay. All right, so test-wise. It was 2.5, which was a whole bunch of scatter plots, which I don't think I need to worry about.
Are we, that's on the test, right?
Well, you have to use scatter plots to do everything else,
Are
don't
we
you?
using calculators for all of this, or
Yeah.
just like the section product? But, okay, wait,
Oh, these are the sections.
for those scatter plots,
These
you
are
have to do like the thing where you like fit the line.
I'll get there.
Okay.
When you're talking about 3.4, that was your linear programming. Those are the word problems, maximum, minimums, find the intersection points, that stuff. Going through all of my notes and things, I found 3 problems that we have not done yet. So each one of the classes gets one of them. Yay! Very exciting. Then it was 5, 7.
8, I think.
It was something like that. It was exponential. No, I'm sorry. This was, first one was quadratic. It was quadratic regression. That's when you had to do these systems of equations with 3 variables, 3 equations. I'm not giving you that because it takes too long. Not like that.
So it'll be.
But you still have to know when to use quadratic.
Problems were those, like, what, it was
The system of equations.
Remember the 3x3 matrix we did?
Oh,
Then we did,
Just take it and you put it in the 6, 9.
it was 6, 9 was your polygons. This is when we started to do a couple of different things. When we did the polygon regression, we spent more time in it. We did the subtraction off the table to figure out the degree. The finite regression stuff. To figure out whether it was quadratic, cubic, quartic. We did write the equation of the polynomial given 3 intercepts and a point. Remember you had y equals a, x, that stuff. You'd solve for a, resubstitute back in. We did that.
Wait, so 3.4 is like the word problems?
Wait, how did you put the
Constraints.
matrix thing on the calculator?
You don't have to worry about it, I'm not
I
making
don't
it.
have that in here. Did I miss that?
linear programming.
Then it was,
Yeah.
exponential.
And then this stuff. Actually, there's section 8.
Exponential, the first thing we did was wrote equations. That was really easy. AB to the x. You were given two sets of points. Use substitution, solve for a, solve for b, rewrite it out. You also did exponential regression. Exponential regression is when you had your L1, L2, and it looked like this. But in order to show that it truly was an exponential regression before you hit the button, you had to do what?
Like, make it linear and
Natural
by
log
making a third.
Right, make it linear-ish by showing your
Third list with
The
the
L3
natural log of the second list.
correct natural log of your second list.
That's
Very
all
good.
it said.
Yeah. So that's how you did the natural log stuff, and it was just a straight calculator, and then you were able to write out your equations. Pretty straightforward. Then we did the 8-8 logistic stuff, and that's when you had your always increasing asymptotes, and you had that point of maximum growth.
Is it possible for it to be decreasing?
What do you mean?
Well,
No, logistic. One of the reasons that it's called logistic is it's always moving from left to right. It's always going from left to right, increasing.
Nah, the one on that wrong.
I know. Yeah.
So tomorrow is set for review, or, no, it's today?
Today's.
Today's-
Tomorrow's Friday.
My days are off, I'm sorry.
You had to be able to find this maximum point. Remember, it was pretty simple. It was that natural log, natural log of A over R, C over 2.
Oh my gosh, this is much. Oh.
Yeah,
Um,
I use 5, 8, sometimes 7.
Oh, shucks.
You had to solve, remember, I had you guys do a couple where you had to solve for X?
Yeah.
I had to throw that at you.
Those were easy.
And the last one was your regression of
You just have to-
sinusoid.
But just like a
How do you
fine-
undo E? Wait, you take the natural log.
What we just did? Sinusoid. So remember, depending upon what your graph looks like, a lot of these times, if you're given a set of table, if you're given your set of tables and you're looking at your graphs, it's going to help you to decide which of the regression calculations you're going to get. So if your table looks like this, which regression are you going to use? Sinusoid regression.
Yeah.
There's a button for it.
Oh, there is?
Yeah, it says sign right. That's all it is.
Wait, why did, like, we just did in our.
Is it in like your,
That's exactly what you do. Same thing that's in there.
where, what,
How many questions on this test?
I don't know. Less than 30.
Less than what button
What's
is
it,
it on?
30?
Calculate, it's on your calculator.
Where is that? Oh, that's stat, edit. Oh, no, stat.
Not really, but if you had to, it's pretty, it's just the same thing. You just press the button.
I need to like
Sign.
review.
Oh, it's C.
Oh.
It's letter C.
Is it letter C?
It is.
Letter C, letter C.
Not quite.
I gotta change that picture.
Back to when you were
Because you're
bald.
bald.
No, because my kids are bigger.
I forget what he looked like. You should.
You would look a lot scarier back.
Yeah, it's kind of scary, honestly. Like, I was afraid the first day of class.
Really?
I was like, oh man.
You look
I'm still a little
Oh,
crazy.
You look how human. I got mad.
Yeah, I
Like a nicer father figure.
Yeah, you look like a dad.
Like, hey, Dad.
Before you kind of look like a scary homeless person.
Wait, what did you say when you roasted him?
I don't know.
The gravy boat?
Something, it looked like, yeah.
I pulled the gravy boat out.
I get a cop a lot.
It wasn't the mother.
It looks like a coke.
You look like a biker.
A biker?
Yeah.
I don't know what's this called. Like,
On a chop.
yeah, sure, whatever. Take it, me. I'm
Hog ray. Stopping at random bars along the road, searching for his lost soul.
No, I feel like keeping the
There's a button that says sign right.
So that does what we just did in our head when they give us more than 2 points.
Yeah.
Alright, next.
Wait, what do you use sign right for? Like,
If yours, remember yours, if your table set looks like it's gonna go, it's showing like a periodic looking thing.
I feel like we never did that. We did ever do
You
that?
don't really need to. Why waste our time? It's so easy. You look at the table. The table starts, goes up, and comes down, comes back up where you start. It's a sine curve or a cosine curve.
so is a lot of this just gonna be writing equations that you get out of the calculator?
But you're gonna have to, yeah, because you're gonna have to be able to look at a table and say, okay, it's this.
Alright.
Okay, it's that.
And in order to do that, we do the one,
Your financial does that work? Trying to think if there's anything else that's crazy.
You just have like some practice problems,
The what?
little like links with like extra problems, like you sometimes do.
I don't really have anything, because we've done so many of these, I don't think there's one left, except for I had to come up with those tests. There's only so many of this
Do you
stuff.
like design the tests, like do you like make up the problems, or do you use the questions?
I do a little bit of both. I take a lot of problems, and I manipulate them to make it work for us, and then I have to change them up for the different classes, so.
So we don't get the same exact test with like third hour, and then 12th hour doesn't do the same test with third hour.
Don't you, they have there's a lot of similarities, but there's enough differences that it's worth it.
That if you tell someone, okay, the answer to number 10 is this.
Yeah. With math, it's very easy to assess what you're supposed to be learning via different problems. Whereas there's only one capital of Georgia.
I don't know what that is, but yeah, you're right.
think so.
Trying to join DHS robotics.
I feel like
new, but
that's like, I feel
I
like that's
don't
like
know how New York is. I can only tell, like,
Point it out.